In this video, we're going to talk about solving systems of two linear equations using the substitution method. So I've drawn a system of equations right here. And with the substitution method, the way this method works is you take one of the variables in one of the equations and you solve that equation for that variable. Okay, meaning you get that variable all by itself on one side of the equation. Okay, now even though you can pick any one of the variables, okay, either variable in either equation, it's often easiest to pick a variable that has a coefficient of 1. So for example, this coefficient of x in the first equation is 1. So I think it's going to be easiest to solve that first system for x. In fact, all we have to do is add 3y to both sides, and we get x equals 3y plus 17. Okay, now we're going to take this 3y plus 17 that x is equal to, and we're going to plug it in for x in the second equation. So what we get is 2 times x, but x is 3y plus 17, plus 7y is equal to negative 18. Okay, now notice we have just one equation with one variable, y, and we can solve it for y. So let's do that. We distribute the 2, we get 6y plus 34 plus 7y is equal to negative 18. Combine our y's, we have 13y plus 34 is equal to negative 18. Subtract 34 from both sides. We get 13y is equal to negative 52, I think it is. Okay, 13y is equal to negative 52. Now, we divide both sides by 13. And what we see is that y is equal to negative 52 over 13, which is negative 4. So y equals negative 4. That's the y value for the solution. Now, how do we find the x value? Well, you can take one of these original two equations, or in fact, you could even take this equation over here, and plug in 4 for y. Okay, no matter which one you pick, you should get the same answer for x. So let's actually take this one over here. Let's plug in, minus 4 for y. Plug in minus 4 for y. And let's see what we get. We get negative 12 plus 17, that would be 5. And so x equals 5. So x equals 5 and y equals minus 4 is the solution. So that would be the order pair 5 comma minus 4. And you can go ahead and check for yourself. If you plug in 5 for x and negative 4 for y into both these original equations, they'll both be true. Okay, so that's the substitution method. Let's do one more example. Solve using the substitution method. 4x plus y equals 3 and negative 2x plus 5y equals 37. Now notice I do have one variable that has a coefficient of 1. It's the y in the first equation. So we're going to solve that first equation for y by adding negative 4x to both sides, or subtracting 4x from both sides. We get y equals negative 4x plus 3. So we're going to take this negative 4x plus 3 that y is equal to, and we're going to plug it in for y in the second equation. Okay, y equals that, so let's plug it in for y. So we have negative 2x plus 5 times negative 4x plus 3 is equal to 37. Okay, we distribute the 5, we get negative 2x, I guess it would be plus a negative 20x, or just minus 20x, plus 15 is equal to 37. Combine our negative 2x and negative 20x, we get negative 22x plus 15 is equal to 37. And subtract 15 from both sides, we get negative 22x is equal to 22. Okay, 37 minus 15 is 22. Divide both sides by negative 22, and what we're going to see is that x is equal to negative 1. Okay, so that's the x value of the solution. How do we find the y value? Well, take one of these equations. Again, I like to take this one that we solve for the one variable. Plug it in there. Okay, so y equals negative 4x plus 3, but what is x? X is negative 1. Okay, and negative 4 times negative 1 is positive 4, and 4 plus 3 is 7. So y equals 7. So negative 1 comma 7 is the solution. Okay, and again, you can check that when you plug in negative 1 for x and 7 for y, both of these equations are true. Now, in both of these systems of equations that we just did, our solutions were whole numbers. Okay, -1 and 7, they're whole numbers, but they could involve fractions. Okay, so there might be some problems that you have to do where your solutions do involve fractions.